local little overdensities that I was mentioning a little while ago, which is of course the stars and galaxies. Without the overdensities, without those sort of clumps of matter here and there, of course we would not have galaxies and stars and us and things like that. So even though the universe is largely, as in on a large scale, very homogeneous, very isotropic, as in homogeneous, about the same everywhere. Isotropic means no matter which direction you look in, it's basically the same-ish. There's still, on a smaller scale, on a local-ish scale, of course, there's those irregularities. Can ours recollapse? That's a great question. We will get into it. These are thoughts to have developed from small difference. These are thoughts. So the local irregularities, such as stars and galaxies, are thought to have developed from small differences in the density of the early universe from one region to another. What was the origin of these density fluctuations? So the fact that at a local scale, there are fluctuations in the density, these fluctuations, basically fluctuations meaning over densities, having a little over density somewhere is sort of this fluctuation of the density, right? Very tiny fluctuations, because remember, we mentioned the smooth universe a lot when we talked about cosmology, and that's basically overall, for the most part, the universe is smooth. It's really a higher order effect that there are these little fluctuations in the density. Sometimes they're called high order perturbations. So higher order perturbations of the smooth universe. That's actually the sort of this topic formally, and those have led to the galaxies and the stars. But we have to probe and try to understand why there are even those fluctuations. Why are there these higher order perturbations? So this is a very important question in cosmology, because of course it leads to large scale structure, galaxies, stars, and there is a belief that dark matter actually has some role in this. So we'll try to figure it out. We will see what these people say about this topic and probe this, but that's kind of what, the overall feel of it. So as far as can ours recollapse, so basically we are expanding at the critical rate where we should avoid a recollapse. But also we're not, so if we expanded at a rate smaller than the critical rate, then we would have recollapsed by now. It would not have gotten to the present size. The universe has gotten a lot bigger than it used to be, and we would not have gotten to this size if it recollapsed earlier, obviously, right? But we're expanding at exactly the critical rate, which is a very interesting phenomena, because we could also have been expanding at a much faster rate. And by the way, I would take this exact rate of expansion. We talked about this a lot during our cosmology specific lives, where we were consulting with the reference book by Scott Dodelson. And remember that to figure out this rate of expansion, you have to basically fit your cosmology model to what you're seeing in observation, and then kind of understand the rate. So measuring the rate is not so trivial, right? So take it with a little bit of a grain of salt, because ultimately they do fit the model to the data and figure out the critical rate of expansion from there. But basically there is definitely some possible numbers, right? If you expand too fast, then you're never going to recollapse. If you expand too slow, then you could recollapse. And it seems like we're in the ballpark of where we will not recollapse. And that too is a bit of a mystery as to why that is. Why are we expanding at a rate that is sort of the critical rate, or in the ballpark? I don't know how much it's exact. I have to, learn more about that. But as far as the ballpark of where we are not supposed to be recollapsing. Or basically, if this critical rate was not the case, then we would have recollapsed by now. The universe is very big already. We wouldn't have made it to this current size if the recollapse was going to happen. Thank you so much for the hearts. Can we get 10 likes? Can we get 20 likes? That would be amazing. The general theory of relativity